this chapter 6 as well. Okay? We're going to do 4 and 5 back to back because they make the most sense together. We're going to take a break and then we'll do chapter 6. Okay, 6 trigonometric ratios. We've expanded, so all of your life you thought there was only 3. Well, there's actually 6. Okay, give me the ratio for sine. Opposite over hypotenuse. You guys are brilliant. Cosine. Thanks. Hey, ladies and gentlemen, how come I only have some of you with me today? I know you're physically here, but you're doing something else. I know, it's hard to believe. I would even suggest such a thing. And tangent, opposite over adjacent. Okay, you guys are now going to learn the reciprocal function. So those ones we know like the back of our hands. Trig, super easy. Now we're going to do the reciprocal functions of them. So cosecant is the reciprocal function of sine. So
who decided that was what it was supposed to be called?
It's not a cos?
No, it's of sine, yeah, just to mess with you. Yeah. So cosecant is the reciprocal function of sine. I want you to read your page. You read your page and you tell me what it says. Probably, because that's what it says on your page. Yeah. Yes and no. You can do it that way. A lot of people do because it makes more sense and then just flip it. Right? Yeah, exactly. Or you can do cosecant theta. If the original one was opposite over hypotenuse, what would be the reciprocal of it?
How does this help us with that?
It's expanding your knowledge base.
If it's cosecant for sine.
But secant is cosine?
What?
But secant is cosine?
Okay. I need you all just to take a big deep breath. Okay, sine and cosecant are the reciprocal functions of each other. Okay? And then we have cosine and secant, who are the reciprocal functions of each other. So yes, it's confusing because sine should go with secant because they're both S's, but that is not the case. It's always opposites. So this is going to be, so secant theta is equal to 1 over cosine. Or how else could I write it? Yeah. Hypotenuse over adjacent. So what some people do, like what Danica was saying, could I figure out cosine, just figure out what that is, and reciprocate it in the end? And that's totally a fine way to deal with it. No problems there. Or you could jump right to here and put it into the equation reciprocated. Okay, and tangent goes with cotan. Life is good.
That would be cosine over sine.
Yes.
Okay.
Yay.
I remembered the original thing.
Yay. Okay. I just realized I didn't put this down. And remember that tan theta is sine theta over cos theta. Do you guys remember that? Sort of, kind of? So cotan is the reciprocal. So it would be adjacent. Well, we could write it as, sorry, I'm running out of room. Cotan theta equals 1 over tan. Or we could write it as adjacent over opposite. Or we could write it as cosine over sine. So tan has just a couple different ways, just because tan's a little bit more complicated. Nicole, what are you doing? Danica is looking at your phone and giggling uncontrollably.
What Not even. She was perfectly fine.
She's perfectly fine? Is that what's happening there? Okay, all right. Okay. So those last three that we did are called reciprocal functions. And you've got to figure out a nice way to remember. I think that, reciprocal, kind of opposite, sine goes with cosecant, like sine C, cosine goes with secant. I don't know. It's kind of backwards, it's kind of opposite, it's kind of reciprocally. Okay, so anytime I'm asking for exact values, you guys know that it's in terms of pi, it's a root, you never convert it to decimals, right? Because that's bad. So what's cosine of pi over 3? You got two options. What quadrant are you in? So you know it's going to be positive, right? Like we know that for sure. And my options are going to be either 1/2 or root 3 over 2.
Oh.
Oh.
Because cos is x and sine is y, right?
Cos is x and sine is y.
So
It's 1/2. Okay, can I draw you another handy way of remembering the order? So this is pi over 6, pi over 4, pi over 3. So the way that I remember it, I call them long shorts. If you do root 3 over 2 in your calculator, let me use my calculator. Root 3 divided by 2, I get a decimal of 0.866. And then what is 1/2 as a decimal? 0.5. So would you guys agree that this one is a greater number? Like it's a bigger number than 1/2? Okay. All right. So I call these the short longs. So when I draw this triangle in, which one is longer? Is the x longer or is the y longer? So right away, if the x is longer, I know it's root 3 over 2. Okay? And 1/2. So I'm changing it to pictures. Then, if I'm doing this one here, I just found this random marker on my desk. Is the x short or is it long?
Short.
It's short. So guess what my x is? 1/2. So I know the other one has to be root 3 over 2. So I just call it the short longs as I'm making the triangles. 45 is the exact same, root 2 over 2 and root 2 over 2. So I don't need to know which one's x and which one's y. I just need to remind myself that anything with a denominator of 4 is root 2 over 2. So yeah, that's just another handy way, the short longs, to figure out where you are. So if you're a visual person and pictures make more sense, draw the triangle. Okay, well, you guys weren't as impressed with that as I was hoping for, but I'll roll with it. Okay, so secant of pi over 4. 2 over root 2. So the first thing we're going to do is what reciprocal function is secant for? Cosine. So we're going to have, if we figure out, Danica, this is the way you wanted to do it. If we figure out, this is the easy way. So what is cosine of pi over 4? Root 2 over 2. So therefore, what would be secant of pi over 4? 2 over root 2. Could you rationalize that denominator for funsies? The answer is yes, you need to know how to do this. So even though it's, you maybe don't want to, you probably should. Right? So that's rationalizing the denominator. This has a value of 1. So you're not changing the value of it, you're just changing the way it looks. So that's going to be 2 root 2 over 2. Cancel out the 2's. Okay. Okay, we've left the station. We have left quadrant 1. We've left it. We've left it behind. Okay? What quadrant is 2 pi over 3 in? It's in quadrant 2. Okay, cosecant is the reciprocal function of sine. So we know in quadrant 2, sine is positive. So understanding and knowing your, like just your CAS rule and where you are like angle-wise is pretty critical to this unit and the next unit. Okay, so we're looking for sine of 2 pi over 3. Yes. Good job. So root 3 over 2. So what is cosecant of 2 pi over 3? Right? We got to do the reciprocal of it because sine, sorry, I shouldn't have put that there. Sine is root 3 over 2. Now, ladies and gentlemen, I got to stress to you that if you're going to use this method, you need to make sure you label them appropriately. Don't start slapping down just root 3 over 2 and then 2 over root 3. I need to know that you understand that sine is this and cosecant is that. Let's rationalize that denominator for funsies. Meh. Can I simplify that one? No, I cannot. So this is where your calculator gets taken away, right? So I'm going to tell you that your chapter 4 test is going to have a significant portion of it without your calculator. So here's my question. No, I don't have a question. I was going to take your calculator away for the quiz, but I think that will be too much too soon. Okay. Cotan. So remember that tangent isn't a coordinate on the unit circle. You actually have to figure it out. Okay? Yeah. Yeah. Okay. All right. So what quadrant are we in? Let's start always where we're located. So this is in quad 2. And what do we know about quad 2 and tangent?
I got it right.
Yay! So quad 2 tan is negative. And we know that cotan is the reciprocal function of tan. All right. Here we go. So for me, the easiest thing to do is figure out the coordinate at 5 pi over 6. And I'm going to, can you do it without the unit circle, thinking of short longs or cosine 1, 2, 3, 3, 2, 1? So the coordinate at 5 pi over 6 is?
So square root of 3 over 2. But it's negative.
But it's negative, right? Okay, so for me, the easiest way to do it is putting it into this formula. Cotan of 5 pi over 6 is equivalent to cosine of 5 pi over 6 divided by sine of 5 pi over 6.
That's just a really fancy way of saying like minus square root of 2
You're not.
and divided by half, right?
Yeah.
Okay.
So what do we know?
Formula though, then?
You don't need the formula, but that's the easiest way for me to do it, and if I don't show all my steps, I get in trouble.
Okay.
So what is cosine of 5 pi over 6? Negative root 3 over 2. Now what does this symbol mean? What does that symbol means divide. Okay, so I'm going to write it like this. Can you do this without a calculator? Yeah, maybe. Let's not rush it. Jeez. So cotan of 5 pi over 6 is equal to negative root 3. Oh, that makes sense. I was like, that's not right, but it is right, because tan is 1 over root 3. Okay. Oh, the next one. The next one.
What is this?
What is this?
Do you have to do coterminal angles?
I would do a coterminal angle right off the hop. Yes, you do. So here, the first thing I'm going to do is I'm going to do a coterminal. So how do I do a coterminal angle? Add who?
So I keep
Add 2 pi. A full rotation, yeah. So we're going to add 2 pi. So that's going to be negative 3 pi over 4 plus 8 pi over 4. Right? I want to get common denominators. And I'm going to be at 5 pi over 4. Okay, so now I'm looking for the cotan of 5 pi over 4. Okay, where are you located at 5 pi over 4? Okay. Okay, what do we know about tangent in quadrant 3? Okay. All right, so I'm leaving it here and you guys are going to figure it out. Figure out what it is. This one's an easy one. Anybody know why it's easy? Okay. Because it's a 45, yes. What?
Oh.
Oh, if you start, like, once you look at it, you should, all of a sudden you should be like, oh, this is easy. What's anything divided by itself?
What about 0?
0. Oh, 0 divided by 0 is going to be undefined because you can't have 0 as a denominator.
I'm gonna die after this. The only thing we're doing is like.
All right. So you should have got an answer of 1 because the two coordinates are the exact same. Negative root 2 over 2 divided by negative root 2 over 2 is going to give you a positive 1. Okay. Now we're going to do the cosine of 29 pi over 6. So what am I going to do here? I'm going to do a coterminal angle again. Okay, so because it's bigger than a full rotation, you guys know a full rotation would be 12 pi over 6, right?
Yeah.
So I'm going to do a coterminal angle because I can't envision in my head where 29 pi over 6 is.
It's 5 pi.
So I'm going to take 24 out. So I'm going to take 29 pi over 6 and I'm going to subtract 2 full rotations from it. Because 29 pi over 6, subtract 2 full rotations, so that would be 24 pi over 6. So I should be left with 5 pi over 6. So I'm looking for cosine of 5 pi over 6. Quadrant 2. What do we know about cosine in quad 2?
Negative?
It is negative. Cos is x.
So it's negative square root of 3.
Nope. Yes.
Yeah, 'cause it's
Yeah.
the long one, yeah.
It's the long one. So nothing has been super hard, like mathematically, the calculations aren't hard, but there's lots of steps that you have to look at before you can kind of proceed. And we're all going to do it a little bit different, and we're all going to have ways that we remember the important information that we have. Okay. Number 7. Can you do that? What's going to be the first thing that you're going to do with a negative angle? Going to do a coterminal. So we know a full rotation. And if this makes it easier for you, actually write it down. Like, it seems such a silly little thing, but sometimes I find people go in rotations of 6 because the denominator's 6, but you got to remember you're looking at the 12.
When we have 48, we're trying to get positive.
Because we got to look at the 12, right? Those are full rotations. So we're going to do 4 of those, which is 48. So we're looking for cosecant of pi over 6.
I thought it was. I mean, never mind. Yeah, okay.
Cosecant is sine. So I'm not even going to write it down. I'm going to get you to do it. What do we know about sine of pi over 6? We do. Sine of pi over 6. Think short, long.
Oh,
It's a half. It's short. The y is short on this one.
So it's half.
So what's cosecant going to be?
2. That's not taking
You have, okay, so go back to your unit circle. What's sine of pi over 6? It's 1/2. So what's the reciprocal of 1/2? Right? 2 over 1. And I'm just not going to write the over 1 part. So, okay, obviously if you're still struggling, use your unit circle because you'd much rather, maybe the repetition of looking at it's going to help, but you've got to get good. You got to get good at knowing where you are on the unit circle and what the coordinates are. Okay, we're going to do some order of operations on this one. Actually, we're not. We're going to multiply them all together. Hey, guess what? This is a question on your test. Probably on your quiz too. So this one's coming up. So I'm going to get you to do an order of operation. It might be an add, it might be a subtract, might be an add, subtract, multiply sort of in there. Okay, so we're just going to treat them as separate first. So what is cos of 30 pi? 1. Okay. What's a full rotation, ladies and gentlemen? 2 pi, right? So 2 pi, how many full rotations can I pull out? 15 of them. And where am I? I'm at 0, or I'm at 2 pi, like I'm right on that line. So you're on the x-axis. So we never talk about this one, but we're on the x-axis. So what's cosine here? It's 1.
Why would it be 1 and not 1? Oh, because it's, okay, never mind, it's okay.
Okay. All right, so now we're going to do secant of 2 pi over 3. What quadrant am I in? 2.
Negative?
So it's definitely negative. And now you got to figure out if it's short, long.
Oh, no, okay.
Get your unit circle out then, Amber. Then get your unit circle out. Get it out, look at it, find 2 pi. Or find 2 pi over 3, sorry.
It's short, then it'll be half, yeah.
So this one we're going to have to do the reciprocal for it. So what do we know about cosine at 2 pi over 3? It's half. It's a negative half. So what's the reciprocal of negative half? Negative 2. All right. Now we're going to do cosecant of negative pi over 3. So what's going to be the first thing I do with that negative? I'm going to do a coterminal. So coterminal is going to be negative pi over 3 plus 6 pi over 3, which leaves me at 5 pi over 3. So I am in quadrant 4. Well, I know that pi over 3 is in quadrant 1, right? So the premise is if I go the opposite way, I'm in quadrant 4. Okay. It takes people different amounts of time to get this, but the more you practice it, it will get better. So what do we know about cosecant? It is the reciprocal function of sine, and we are in quad 4, so we know sine is negative.
So negative square root of 3 over 2. And then reciprocal.
Reciprocals do never change the sign.
So negative 2 over root 3, is that one? I think I figured out a way I'm not taking it in my head. Okay.
If you're not following along, like if you're not getting it, I would jump to these 5 pi over 3. We're looking for sine. We're looking for sine because it's cosecant. So what is the sine? Sine's root 3, negative root 3 over 2. So we're just going to flip it. Okay? Our pop quiz is coming in handy. Okay, so I need to answer the question now, because that wasn't the question. What's happening in between each one of these? I'm multiplying, so I'm going to have 1 times negative 2 times negative 2 over root 3. All I did was I took the answers that we found, each individual one, and I multiplied them together.
Can I do this one?
100%.
I just flipped it.
Yeah, that's fine. Yeah. Let's rationalize that denominator. Okay, I'm waiting. Am I good, Danica, to reciprocate or to rationalize that one? Yeah? Okay. So this is my answer, but we're going to rationalize the denominator. So nice thing about it is you won't do the complicated ones. Am I going to simplify that? No, we're done. So this would be the answer to the question. Yeah, you want to get into the habit of it? Would I mark you wrong if you didn't know? But will you be able to work backwards is going to be my question. Root 3 times root 3 is root 9. And if you take the square root of 9, it's 3. Okay, am I good to flip? Oh, don't worry, it's coming. It's coming. Let's not rush it, Taylor. Let's not rush it. Things will. Okay. All right. Hey, we get to use our calculators, everybody. Yay! That's not good. Okay. So this is where mistakes are made. All right. So what I need you guys to do is you need to check your mode on your calculator. So if you have this type of calculator, what I mean by mode is I want you to make sure you're in the right angle measurements. So you can see this one has a D on the display. Some of you might have a DEG. That means I'm in degrees. First question, what is it in? Radians. You will get the wrong answer if you're in the wrong mode.
Yeah, Mr. Beck told us to switch back to degree mode if we were doing radians to degree top.
Yeah.
Now I'm gonna get confused.
Yeah, and you're gonna go back and forth in this class, so you're gonna get confused just in one classroom. So, if you have a graphing calculator, some of the older ones won't show this, but mine shows that I'm in degrees here. You're right, you're not allowed to have one. Okay, I'll use this one. Jeez Louise. Okay, so I need to change the mode on it. So I'm going to go mode. Is this it? No, that's not it. New calculator. You guys are really messing with me. Oh, here it is. Okay, so on mine, it's right at the bottom here, I think. The DRG, degrees, radians, gradians. Degrees, radians, gradians. So there's a G measure of angles that we're not going to touch. So I have to hit shift and then I come here and it's like, do you want degrees, do you want radians, or do you want gradians? And I want option number 2. Oh, why didn't it go? Okay, that did not change my calculator. I did hit enter. All right, well, this is frustrating. Is everybody in radians except for me? Nice. All right, I like it when I don't know what's going on. Okay, I give up. I'm going to this one because I can do that. I got to go to mode. I go to radians. Oh, thank goodness. Okay, so super easy, but you might have to use brackets. Trying to increase my display brightness. Doesn't seem to work. Okay, I'll get out from under those lights. Maybe that'll, oh, there we go. That's better. Okay, quit. All right, so we're gonna do it. I don't know which way your calculator goes where you have to put in the, like if you have to put in the angle first and then hit the trig function, or if you have to hit the trig function first, like my calculator. So 5 pi, and you want to use your pi button. No, it's 7 pi. 7 pi divided by 5, and I'm going to close my brackets. It's really important. Some calculators will take tan of 7 pi, figure that out, and then it will divide the answer by 5. Whoa, whoa. Things are getting outraged. Well, I didn't have much luck in the other one either.
I tried pressing the mode button, but it doesn't even give the option.
Okay, yeah. I think you are the same problem. Okay, so option 2. But see, yours did the same thing mine did.
I tried almost everything.
Yeah, I gave up. I wonder if you do it like tan. Do you have to put your other thing in first? Like, do you have to put, okay, let's do cosine of 30. Okay, so you put it in the same way I do. So tan bracket 5, where's your pi button?
It's right here.
Okay, second is that, divide by, oh, I did it backwards. 7, divide by 5, close my brackets, and I'm, this, 2, I don't know, I'll have to come back to it. You're just gonna have to follow along, and when I figure out Casio calculators, I'll do my best. I cannot fix your physical calculator.
It's brand new though, so like it's definitely not broken. I tried that one. Like bracket.
So you're in radians now. Your brackets, oh, see, like they don't put them around them. They show them up there.
Like my answer doesn't.
Okay, so we're gonna go 10. Okay, so we've got to do 7. Where's your pi button? 7 pi divided by 5. And then we're gonna go tan of that. Okay. Yeah. Okay. All right. Yeah. Yeah. I haven't hit my equal sign yet. I get the same answer. Yeah. I hadn't hit equal yet. Okay. So I think you need to use your brackets. I think your calculator's doing tan of 7 pi, and then it's dividing your answer by 5. Okay. I think it's the same problem I have right here. Okay, that was long and painful, and I apologize if your calculator's not working. Okay, did you use your brackets?
They didn't work. They go at the top, but they don't actually go in.
Okay, you guys are killing me.
Unless I'm just.
Okay, so we're gonna go bracket 7. Where's my pi? Divide by. Okay, let's try that again. Bracket 7 pi divided by 5 equals. Okay, I got that. Now I'm gonna do tan.
How do you know? Oh, okay. No, there is actually.
I have no idea. I'm gonna move on and we'll work on your calculator. So, okay. For those of you who have a functioning calculator, you found it?
Yeah.
Okay.
It was on the back of my calculator case.
Oh.
There.
Let's see if it's on the back of mine. Probably.
There's more twice.
Okay.
Yeah.
I hit mode twice, but it didn't work.
I'll show you.
Okay, you fixed. Okay. Anybody else with a working calculator get this for an answer?
Yeah.
Yes. Let's go to 4 decimal places. That is 777. Okay. Now we're doing cos. We're doing cos of 260. Where is 260 on the unit circle? What quadrant? What do you anticipate your answer for cos to be? You should get a negative here. What did you do?
I pressed shift and mode. So shift, mode, and this all comes up.
Oh,
It's this one.
okay. Wow. All right. Thank you for helping me. Okay. Next one. So this one's in degrees this time. So I got to change my calculator. You will not get the right answer if you're in degrees.
Convert it to radians. Why do we have to go back and forth?
You're going to go back and forth. Did you guys get that for an answer? If you have a working calculator?
How do you change it back?
What? There's been no reciprocal functions. Yes, that's exactly how you do it. Because if you look at your calculator, there's no cosecant, there's no secant, and there's no cotan.
There's cos negative 1 though, does that work?
No, that finds your angle.
Okay.
So because you don't have reciprocal functions, if this were a reciprocal question, you'd have to take this and put it under 1. Does that make sense to everybody? And actually do the math there. Okay, here we go. So let's double duty here. What's the first thing I'm going to do with this? What's the first thing I'm going to do of this?
Co-terminal.
Coterminal.
At 360.
Okay, you two are having way too much fun over there. The rest of us are barely hanging on. So if I have my calculator here, can I do cosecant in my calculator? No. So I'm going to do in my calculator sine of 290. Hey, where are you at 290? 4. So what do we anticipate sine's going to be in quadrant 4? Negative. Okay. So we're going to do sine of 290. Okay, hold on though, we're not rounding, this isn't our answer.
So for the entire thing.
Yep.
Oh, great. Okay.
Ooh, forgot a 2. Good. Okay, good, everybody. You didn't or did? Are you in radians? Because you need to be in degrees. All right, so if I want to find cosecant of it, okay, so here's the thing. If you know how to use your answer line, this becomes, like if you have a memory feature or an answer from the previous line, this becomes a little bit easier to do. Because I can simply go 1 divided by second function, and I hit my negative button and see how it says ANS above it. It pulls the answer from the previous line for me. And so cosecant of 290 degrees is negative 1.0642. Okay. What are you going to do here? 2 full. So we're going to do our coterminal first. So we're going to have negative 500 degrees plus 720, because that's 2 full rotations. Is it better if I write it as like 2 times 360? Does that make more sense? You guys don't care now? You're just golden with this? You've lost your mind. So secant of 220, what quadrant are you in? So what do we anticipate cosine to be? Negative. All right, so cos of 220 degrees is negative 0.7660. How many 4s are there? 1, 2, 3, 4. There's 4. I had to stop and count them. So if we want to find secant of 220, I would encourage you, ladies and gentlemen, if you're going to be doing math courses or physics courses or any course that requires you to do math in it, you really should get a decent calculator that you're going to keep into university and that you'll practice with this year. My favorite are the TIs, but Casio isn't too far behind with that. I just don't like their graphing calculator. Yeah?
Do we have to do write these right now? Can we write like 0.7660444 dot dot dot?
Yep. Okay. As long as you use it.
Okay, yeah.
Does that make sense?
Okay, got it.
So Basil asked a really good question. He said, do I have to write all this down? Could I just use an ellipse to show that there's more numbers after it? Absolutely, but you must use all the decimal places. Okay, so just because you don't write them down, you can substitute with an ellipse in there, but you have to use all the decimal places. So I'm going to write them all down just to remind us that we have to use them. Okay. Oh dear. We still have more. We still have more. It's good times. Okay. Guys, let's change this restriction. Yep. Okay, I'd like you to change that restriction to negative pi. All right. Are you guys ready? Okay. So if you are not comfortable with the unit circle yet, I need you to get it out. Okay? I want you to have it in front of you because this is going to get confusing. All right. Here we go. Here we go. All right. So this question is asking cosine of 1 over root 2. This point is on the unit circle. I want you to rationalize this denominator to see it. So if you rationalize that denominator, we'd be doing cos theta of root 2 over 2. Is it positive or negative? It's positive. It's right there. It's positive. Okay, what quadrant is cosine positive for? So cos is positive in quadrant 1 and quadrant 4. So there's your cast rule, right? Okay, so that's on a full positive rotation. Everybody with me so far here? Okay, so if we look at this, cosine's positive at pi over 4, and cosine is positive at 7 pi over 4. Do you guys agree with me? Yes? Okay, those points don't change. They are locked into place. Our angle measurements are based on our restrictions. Everybody ready? Great, perfect. Nicole, we're going to do the positive rotation first. This one's the easy one. Okay, so we're going to deal with our positive rotation first. We just found them. Where on the unit circle on positive angles do we have cosine at root 2 over 2? Pi over 4 and 7 pi over 4. Okay, so we have two answers there. So theta can equal pi over 4 and 7 pi over 4. All right, good job, everybody. We're not done, though, because that's not how we roll. Now we're going to deal with the negative rotation. Okay, is it a full negative rotation? No, it's not a full negative rotation. What is it? It's half of a negative rotation. So again, my points don't change. They're here and here, but this time I'm measuring I'm doing my negative rotation, right? But I'm only doing to negative pi. So that's this bottom half of the circle because we're going negative pi. Everybody with me? Okay, so how many answers do I have in this one? One. I only have that one red dot. What is it? Negative pi over 4. So if I'm traveling this way, I've only traveled a quarter of a pi to get to that point. If you're not sure, if it doesn't make sense, like if it's not a quick one, you can do a negative coterminal angle for 7 pi over 4.
Can't you literally just look like 2 lines up and then make a negative?
100% you can. But some of them aren't that nice. Like if we're dealing with 2/3 pi.
I just count.
Okay, or just count. Yeah, like you can totally just count. So what's our answer in the negative? Theta is equal to a negative pi over 4. So you have 3 answers in this one. You have 2 when we measure in positive direction, and we have 1 when we go to the negative. Because what is it? It's not a full rotation, it's negative pi, so it was only the bottom half of that circle. Okay, guys. You ready? Okay, reference angle here. It's way easier to do without a calculator. Maybe though we should we stop? Maybe we should stop. Okay, ladies and gentlemen, we're going to do 2